Rodney Kowecki's expanse vacuum gravitation theory presents a novel perspective on gravity and faster-than-light travel, proposing that the fabric of space itself possesses repulsive properties that can be harnessed for propulsion. Space as a repulsive medium. Kowecki suggests that, contrary to traditional views of gravity as an attractive force, the vacuum of space exerts a repulsive force. This repulsion is thought to drive the expansion of the universe and can be utilized to propel spacecraft beyond the speed of light. Reverse vacuum space field drive. Building on this concept, Kowecki introduces the idea of a propulsion system that leverages the repulsive nature of space. This reverse vacuum space field drive would allow a spacecraft to achieve velocities exceeding that of light by interacting with the expansive force of the universe itself. Differentiation from traditional gravity. The theory distinguishes between planetary gravity, denoted as little g, and cosmic gravity, big G. While little g pertains to the gravitational pull experienced on planetary bodies, big G refers to the expansive, repulsive force of the universe. Kowecki posits that this big G force can be harnessed for faster-than-light travel. Space acts just the opposite of matter resistance. After the Big Bang event, as matter cooled, the activity resistance caused matter to spin at great velocity. This spin caused the dark space element to entangle, creating a vicious spin. In the three-dimensional space, rather than forming a black hole, the main element of cold in the formation of a bubble emerged and has been expanding ever since. Conceptual stages of the illustration. Post-Big Bang chaos, a vibrant central explosion representing the Big Bang. Surrounding this, cooling matter begins to condense into fragments and filaments. The space between these fragments, the dark space element, resists, visualized as a dark semi-fluid web or ether pushing back against matter's activity. Matter begins to spin rapidly due to the resistance of space. Picture swirling vortexes of galaxies or protomatter clumps, each spinning in multiple directions. It's a mesmerizing dance of cosmic forces at play. Arrows and motion trails emphasize angular momentum. They highlight the intricate paths and the dynamic nature of these celestial objects. The spinning matter entangles the dark space element. Imagine thread-like dark tendrils wrapping around the spinning objects, binding them in a cosmic embrace. Visually, this could resemble the beginnings of gravitational fields, but with a chaotic reactive quality.
How do you recognize it?
Instead of a black hole collapse, a cold core bubble emerges, maybe from a convergence of entangled space elements.
I propose.
This bubble becomes the expanding universe.
Before we do that, I have a question.
The bubble is cold, glowing faintly blue-white, surrounded by darker, turbulent regions.
How did this warp?
Three-dimensional space around it is warping outward, indicating expansion.
Enemy bombs fell on the runway in a surprise attack.
The quantum physics theory introduces a novel gravitational paradigm wherein space-time curvature and gravitational interactions can arise independently of traditional energy momentum sources. Rooted in the re-examination of Einstein's field equations, this framework proposes that spatial homogeneity, anisotropy, and dynamic expansion may act as intrinsic sources of curvature and gravitational behavior. The theory integrates Newtonian mechanics, general relativity, and quantum principles under a unified, non-energetic gravitational schema, offering alternative explanations for phenomena such as cosmic inflation, dark energy, and large-scale structure formation without invoking exotic energy components. Imagine if gravity wasn't just about mass. Imagine if the shape of space, its flow, its stretch, its very texture, could bend the universe without a single atom of energy.
I'd like to know more about your enemy.
That's the heart of quantum physics theory. It's a new way to look at gravity, not as something caused by matter, but as something that emerges from space itself. From the tiniest quantum vibrations to the vast swell of cosmic expansion, this theory reimagines gravity as a consequence of the universe's structure, not just its stuff. If Einstein showed us that space tells matter how to move, quantum physics suggests that maybe, just maybe, space can tell itself how to curve.
Sir, if you would go back and talk to the panel.
Quantum physics, a non-energetic gravitational framework.
It would be my pleasure to show you this.
This proposal seeks to explore and formalize the quantum physics theory, a framework which posits that gravity can originate from geometric and dynamic features of space itself, independent of classical energy momentum tensors, by modifying Einstein's field equations to account for curvature driven by spatial anisotropy, homogeneity, and vacuum expansion. This theory aims to unify gravitational phenomena across Newtonian, relativistic, and quantum domains. The anticipated outcome is a robust mathematical and conceptual framework that addresses unresolved cosmological challenges, including the nature of dark energy, the behavior of inertial frames in expanding space, and gravity's role at quantum scale.